Welcome to our Knowledge Bank series, where we share detailed information about major pollutants in the atmosphere. Today, let's talk about one of the most dangerous pollutants. Let's talk about nitrogen monoxide. Did you know that nearly 78% of our air is nitrogen? In its natural state, nitrogen gas is stable and harmless. But under high temperatures, it reacts with oxygen to form nitrogen oxides, one of the most significant contributors to air pollution. Let's understand NO in detail. Nitric oxide or nitrogen monoxide NO is a highly reactive colorless gas with a distinct sweet odor. While it plays vital biological roles in the human body, its presence in the atmosphere tells a different story. NO is released mainly from vehicles, industries, and power plants. Though not very toxic itself, it quickly reacts with oxygen to form NO2. A harmful pollutant linked to health and environmental problems. NO contributes to the formation of ground-level ozone and acid rain, affecting ecosystems, water bodies, and agriculture. With urbanization and industrial growth, NO levels continue to rise, making air quality monitoring more critical than ever. Understanding how NO forms is key to addressing its impact. And it all starts with identifying and controlling its major sources. So let's talk about NO sources. Nitric oxide, NO, is a highly reactive gas that plays a key role in air pollution. While it forms naturally, most of it comes from human activity, mainly high temperature combustion. Major human-made sources, cars, trucks, and buses emit NO due to fuel combustion at high heat. Power plants, cement kilns, and incinerators release NO through burning fossil fuels. Burning coal, biomass, or other nitrogen-rich fuels adds to NO levels. With temperatures hotter than the sun's surface, lightning triggers NO formation by reacting nitrogen and oxygen in the air. Microbes in soil and forest fires also emit small but noticeable amounts of NO. While NO is naturally present in the air, human activities release much more of it. This extra pollution makes it harmful to the environment and health. Being a priority pollutant makes it important to understand how it impacts the environment and human health. Nitric oxide or NO may seem harmless in its original form, but its transformation in the atmosphere tells a different story. Alone, NO doesn't pose a direct threat, but the problem begins when it reacts with oxygen to form nitrogen dioxide NO2. NO2 irritates the respiratory tract, exacerbates asthma, and reduces lung function. It also plays a major role in the formation of ground-level ozone, O3, a pollutant linked to chronic respiratory diseases and cardiovascular issues. But that's not all. NO has far-reaching effects on our environment. When oxidized, NO leads to the formation of acid rain, which acidifies soil and water, harming forests and freshwater ecosystems. It disrupts biodiversity, accelerates eutrophication, and depletes vital nutrients from soil. NO also contributes to the formation of tropospheric ozone, which damages crops, weakens plant health, and worsens climate change. To tackle nitric oxide, NO, pollution effectively, it's essential to focus on reducing emissions and take corrective measures through smarter and sustainable practices. Nitric oxide emissions are a growing concern. But what can we do to control them? The first step is continuous monitoring. Devices like ozone provide real-time NO data to track and respond to pollution quickly. Adjusting air-fuel ratios and maintaining optimal burner temperatures can lower NO formation during industrial processes. Technologies like selective catalytic reduction (SCR) and selective non-catalytic reduction (SNCR) convert NO into harmless nitrogen gas (N2). Replacing coal and oil with natural gas, or even better, solar and wind, greatly cuts NO emissions from energy production. Advanced exhaust systems and catalytic converters in vehicles help reduce NO from fuel combustion. Supporting electric and hybrid vehicles is a game-changing move toward low NOx transportation. To monitor nitric oxide (NO) and nitrogen dioxide (NO2) levels accurately, several advanced techniques are used. Now, let's explore the ways to monitor nitric oxide. 1. Chemiluminescence, gold standard. This method uses a reaction between NO and ozone, O3, that produces light. The brightness of this light tells us how much NO is present. NO2 is measured by converting it into NO, giving a complete picture of NOx levels. 2. Cavity attenuated phase. Shift spectroscopy, CAPS, directly measures NO2 using UV light. When NO2 is present, it changes the light's phase shift in a special optical chamber, allowing precise measurement. 3. Electrochemical sensors. These are small, affordable sensors where NO and NO2 create a tiny electric signal when they react inside the sensor. The signal strength shows how much gas is in the air, which is great for real-time ambient monitoring. 4. Metal oxide sensors. Heated to high temperatures, these sensors detect NOx based on how the gas changes their conductivity. They're simple and useful for continuous detection. 5. Differential optical absorption spectroscopy, DOAS. Used for large areas, DOAS sends light over long distances. NOx gases absorb some of this light, and the analyzer measures what's missing to calculate gas concentrations. Continuous NO monitoring is crucial for reducing air pollution, ensuring regulatory compliance, and protecting public health. By learning more about it, monitoring it, and taking small steps to reduce exposure, we'll invest in healthier communities, a cleaner planet, and a better future. We hope this gave you a deeper understanding of NO and its importance. If you have questions or want to explore more, we're always here to help. Stay informed, stay safe, and keep breathing clean.